Can you tell them, yaar?
Yeah.
Hi Saad, Assalamu alaikum. Kya hal? Oh, 10 people already. Okay. Okay, I'm trying to enable my. Fine, I guess. Why do you guess? Kya scene? Hi Saad, Assalamu alaikum. Kya hal? Oh, 10 people already. Okay. Yeah, gotta stop that. Okay, let me lower the volume a bit. I think that's fine. Wanted to do something. Output, virtual cam on. Okay. ठीक है. I'm good here. How are you guys? Did you guys check the video? That's me. Okay, I think I have to restart my Zoom. Sorry. Can I do that? I have to do it. I'll be back in a second. BRB. You see me? Yeah. I'll be right back. New meeting. Hang on, guys, on YouTube. What's up? Kya chal raha hai? 4 views already. Okay, that's good. Let me just. La 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 la. Yeah. Hopefully this time it'll work. Join with computer. Yeah, okay. Can I do that this way? Oh, it's inverted. Why is my camera inverted? Hi guys, welcome back. Can you guys hear me fine? How's the audio quality? Is it better now? I think it should be better now. Okay, let me fix that video settings. Why is it inverted? Touch. Don't mirror it. Why would you do that? ठीक है. Hi Massam, how are you? All right. Did you guys check out the video I uploaded on oxidizing reagents and reducing reagents? Hi Raj on YouTube, how are you? I'm good. Thank you for asking. You guys are very nice today. Normally I don't get that treatment. It's like, so please teach me A levels. Okay, that's fine as well. ठीक है. Assalamu alaikum Arisha. Okay. ठीक है. All right. Chalo, where's Sir Bilal Hamid, sir? Sir Bilal Hamid doesn't take classes on Wednesdays. I take it on Wednesdays. Abdullah, can you close the window here? The sound. Sorry. Just. Okay. Yeah. So, where's my pen? All right. So I had a question with everyone. Okay. So some people you guys can see it later. If you guys don't know, I recorded a video on oxidizing agents and reducing agents. A focus more on oxidizing agents. Okay. And that's uploaded on the channel. We didn't do it live, so probably didn't get a notification for it, but it's there. And there's another video on hydrated salts, right? Now, hydrated salts aren't really in the syllabus. We don't do anything aside from doing calculations. So I just gave a small introduction to hydrated and dehydrated salts and did a few questions, and it's just straightforward. I think the video was longer than it needed to be. That's not part of acid and bases. Salts will be, but this is just hydrated salts just starts and stops in that 15-minute video. It's just moles calculation. It shows up there. It shows up there, right? Okay. On your YouTube channel, or like I do have a YouTube channel, and yeah. Or on Sir, so it's going to be on Sir Bilal's. I was actually thinking also putting it on mine, so my class can also have a look at it. I'll ask Sir Bilal if I can do that. Okay. These are the same classes that are on Teaching Circle by Bilal Hamid. Yeah, I take 2 of those classes out of the 5 on Fridays and Wednesdays. Saturdays, I forget the second day. Wednesdays for sure. World domination? No, but I want to start. Okay, today's lecture will be very small, very short. I'll be vice president? Please, come on. Vice president? That's just a title. Who's the president? Sir Bilal's government? World, Sir Bilal's complete domination. I have a class going. It's live. I'm being, what's the word?
Hi.
Bombed, yeah. Today is a very casual day for us. Okay. Even that's Sir Suzanne. If you guys know him, he teaches computer science. He's pretty good. Yeah. So. Yeah.
Sorry.
Jesus Christ. Oh my God. Yeah. Boundaries. I should be in that other room, but there's a weak internet in there, so I'm outside. Anyway, let's start. So what I wanted to talk about was that we had a small discussion on we had Redox, and Sir Bilal had a good class on Redox, right? Now, what do you guys understand about Redox so far? Yeah. Reducing and oxidizing, yeah. Redox is short for reduction and oxidation. Okay. But, think of it as, if you recall my class, we were trying to see, we had one equation and we were calling it, it's a combustion. Let me just write it down. Carbon reacting with oxygen is your classic case of combustion reaction, right? Can't get any simpler than this. But it's not just combustion, you can also call it oxidation of carbon. Or this is also a redox reaction, right? So there are multiple names for the same equation. Why really? And it boils down to how you're looking at a particular problem, right? Okay. So if you're considered about fuel and fire hazards and safety, you'll probably use the word combustion rather than oxidation. Now, when you say combustion, it implies heavily that a lot of heat is involved. Okay. And if you say just oxidation, it could be a much different, rusting of iron is also oxidation. When iron rusts, glowy pen. When iron rusts, that's also oxidation. Very similar to the equation example above, right? Now, where am I going with this? So today's part is, I'll write down all kinds of different chemical reactions, and we'll just have a talk about them. Okay, different kinds of chemical reactions. So a certain kind of confusion that we have, I want to eliminate that. Okay. Now, one such example was, I think Saad was the one who highlighted in the last class with me, was if this is oxidation, why is it called combustion, right? And it was the same example, but why do you call it? And another thing I want to emphasize on is they don't really ask you these things. They have general terms for different kinds of reactions, right? They can be hard rules to apply those words, but you won't really be tested on those words. But it's a good idea to know what the question, the importance of these words come along, like carbon is oxidizing. A question starts with question. Carbon is oxidizing in the presence of oxygen. That could be a question, start of a question, in the presence of oxygen. Now, it would help you if you just realize that this is just the same as combustion of carbon. It's the same equation. It's the same thing we're talking about, carbon reacting with, or not just carbon, you can have anything, like any organic compound combust to form an oxide, right? So yeah, so a better understanding of these words goes is really helpful. Like it takes you, really propels you in your studies. Okay. Another thing is that there's so many another things today. Another thing is that for organic reactions, which I'll try to restrict my talking, like I will talk about them, but I'll try to keep it a minimum because some people might have done organic. Some people might not have, so I don't want to confuse them. Okay. But if you've done organic, my voice is breaking. Is it still breaking? How is it oxidizing? Saeed Ramis, you were asking? Okay. How is carbon oxidizing? So carbon is oxidizing because we had multiple definitions for oxidation and reduction. One was oxidation, and then you have reduction. Okay. Oxidation was, so the mnemonic to remember this is oil rig, which stands for oxidation is loss of what? Loss of electrons, and reduction is gain of what? Electrons. We're talking about electrons. So oxidation is loss of electrons, reduction is gain of electrons. So one easy way to identify that here is if there's a loss of electrons, it's oxidation. And if there's a gain of electrons by anything, that's reduction. Another way of identifying oxidation is if something is gaining oxygen. And the exact opposite would be true. If something is losing oxygen, it's reduction. In my last class, the first class for Redox, I went over in great detail explaining why a gain of oxygen is the same as something losing an electron. Just so if you guys can look at that video for more detail, it'll clear some ideas. Okay. And the last one was loss of hydrogen. Let me just write capital H. Loss of hydrogen is also considered oxidation. Same reason for oxygen, but the reverse. And gain of hydrogen is known as reduction. Okay. Over here, the easiest way for me to identify carbon is oxidizing is that it's gaining oxygen because it turns into carbon dioxide. Yeah. So it's oxidizing. But if I wanted to count the electrons, I start with what's the charge on carbon over here, or what's the oxidation number of carbon over here? It's a 0. And over here, what's the oxidation number of carbon? It's going to be +4, right? And oxidation number is very similar to what a charge is. So technically, the charge, so to speak, on carbon over here is +4. So the oxidation number, so it went from 0 to +4. That's a loss of 4 electrons. Okay. And so I'm proving, in other words, gain of oxygen is also the same as losing electrons. Does that make sense? Oh, I heard about the annoying guy. Yeah. Are we ready for him? And that's very shameful, Vasa. We were having a talk, we're trying to get education out for free, right? And people are trying to educate themselves, work on their exam, and this one troll shows up. Troll is that's the wrong word. Troll is in a fun sense, but this was sabotage. This is kicking someone for no reason. Alibad. When I found that out, I was very upset. Not very upset, I was just disappointed. So Saad's asking right now, so I like how Saad's really struggling, he's really trying to absorb this information. Yeah, you know, there are different words for things around us, and they mean the same thing. If I could think of a good example. Yeah, okay. So let me talk about other chemical reactions I wanted to talk about today. And let me just pause and just check if people on YouTube are asking questions. Sir, are these classes the same? All right, I don't. Arham Shehbaz, you want me to explain something again? Arham, I think you missed our previous classes, so we're not doing redox. It was just a revisit to redox. I'm not going to do that. Check our first video on redox, which was last week. ठीक है, I think Saturday को हुई थी. So have a look at that, and you'll have a really good idea of what that is. ठीक है, on YouTube someone's asking a question. ठीक है. All right, and also please don't spam the chat. I'll get to the question. I'm sorry I didn't see your comment earlier, but I'll get to it eventually. But don't spam like that. ठीक है. You just. My face cam froze. It's fine for me. Okay, yeah. Okay, let's finally start. Okay, why did I bring redox up and also went over redox one more time is I want you to keep redox in mind while we go through the entire class today. It's 5:20 already. I was thinking this is going to be a 15-minute class. ठीक है? Yeah, I should start my classes earlier. Aram, we were talking about redox, and I'm mentioning the first video, if you watch on redox, you'll get a really good idea what we're explaining, the carbon thing. Yes. ठीक है. I hope that helps. Okay. Now this is going to be a bit tricky because I have a presentation open. I want to use that. Okay. So let me just tell you how many kinds of reactions are and what we're going to go over. One is a combination reaction. Combination reaction, that's one. You can also use the word loosely. Sometimes you use the word synthesize for it. Synthesis or synthesize if it's a verb. ठीक है. Then you have decomposition. You've heard that, decomposition of different compounds. ठीक है. Did you guys like it when Sarzan bombed my class like that? It's like not even shying away, like, no, what's up, hi. All right, and a weird one, my personal, what's the opposite of favorite? Double displacement reaction, or just displacement reaction. Double displacement reaction. ठीक है. Then you have neutralization. Starts with an E. Neutralization. ठीक है. Precipitation. Precipitation. The most confusing one probably because we talk about the least. Precipitation. ठीक है. And there are also things called reversible reactions. So, like, you get an idea. There's a lot. ठीक है. The ones I uploaded, the videos I uploaded yesterday, one was a mole calculation and one was oxidizing and reducing agents. There's a thing called an oxidizing agent and a reducing agent. And it's a quick video on that. I think it's not even too long. It's 15 minutes long. And yeah. ठीक है, have a look at those. It's very self-explanatory. If you have questions, you can ask me in the next class or in the comments. I'll try to answer those. And there are quite a bunch of reactions. I could go on. But these names just mean something. Like combination is not the word combination, but it's derived from the word combine. All right? So let's take a look at what a combination reaction is. A combination reaction I don't like white, how I'm using it. Combination. A combination reaction is when a compound or an element reacts with another compound or an element to form a product that's the combined, it's combined. Combination reaction. Wow. Right? Yeah. Okay. So can you guys think of another example for this? Any good examples for this? Can you guys think of something? That's a combination reaction. Ah, refreshing. Yeah, any examples for combination? Yeah, I was actually thinking exactly that. Carbon reacting with oxygen to form carbon dioxide is a combination reaction. But you would say, no, sir, this is combustion. Like, what's the difference, right? Right? Like, it's not that one's one thing and the other is the other thing. There's no difference between it. It's just how you're looking at a problem. If you're trying to think in the form of like, okay, I need to combine atoms together, you'll call it a combination reaction. But I don't think anyone's ever used, I've never used that word, like a combination reaction. But it's there. People do use it sometimes. Yeah, hydrogen react, there's another one. The equation is wrong, by the way, Shahir. But not to discredit you. H2O reacting with, that's also a combination reaction. Okay. Both of these are also combustion reactions because oxygen is involved and heat is given out. Combustion. How do you spell combustion? Combustion. Is it combustion? Yeah, I forgot how to spell combustion. Did I write it here? No, I didn't. Combustion. Okay. Oh, it was zoomed in. I didn't know. Okay. So do combine? No, it could take place with anything. Anything combining will give you that. Like here's like, why is my phone not on silent? Sorry. Here's hydrogen reacting with chlorine to form HCl. Simple as that. So combination is just, you have many things on the left-hand side and you're forming one thing. They're all combining together. That's the idea. Does that make sense? Okay. And probably if you want to worry about any type of chemical reaction, this is probably the one you don't want to worry about at all because it's written in all the books, but like I've never seen anyone use it. Like, why would you say that? Like, fine, if they're combining, who cares, Yeah. But it could be many things turning into one thing as well. But there's another reaction that's not a combination reaction, which could be a neutralization reaction, which is hydrochloric acid reacting with sodium hydroxide to form NaCl and H2O. Okay. This is a form of a reaction that's not a combination reaction because they're not combining. You can think of them as they're exchanging. Sodium was with hydroxide and hydrogen was with chlorine. Now sodium is with the chlorine and the hydrogen, they're written together, but the hydrogen is with the hydroxide now. Is it just me or sir's name reminds me? Oh my God. Can I kick Noman out of the Zoom class? How do I do that? Isn't this displacement? Yeah, you can also call this a displacement reaction because essentially what's going on is they're displacing. Chlorine was with hydrogen, now it's with sodium, and hydroxide was with sodium, now it's with the other hydrogen. So you can also call it, but this is also neutralization. More specifically, this is neutralization. But your question is, Saad, you're asking, I'm joking, Noman, I'm joking, because of that Aladdin comment. Saad, your question is incorrect, and I'll highlight why. You're saying sir, isn't this displacement? Like, sir, isn't this also displacement is the point, right? Now, you probably should, what a good practice right now is, if you look at any chemical equation, you should try to highlight in your own head how many categories of reactions can this constitute, right? Constitute. Okay, so we have like a lot of reactions. So the last one, the neutralization, is also a double displacement reaction, but it's not any of the other reactions, right? Now, coming back to our favorite equation, carbon reacting with oxygen. I use this because it's the simplest, right? This is combustion. This is oxidation. This is combination, because it's combining. This is also a redox reaction, because whereas oxidation is taking place, reduction is also taking place. Four names for this particular reaction. But more often than not, you'll use the word combustion for it. Why? Because it's more specific, like oxidation could be a more general term. Something can oxidize, that means it can lose electrons. So oxygen doesn't need to be relevant. But when you say combustion, combustion involves what? Combustion, when you say combustion, you mean oxygen specifically is reacting, is taking part in the reaction, and heat and light are coming out. Heat and light is produced. That's what you mean by combustion. And I say combustion because that's different from a very similar reaction, that is rusting. Okay, does this make sense? How many of you have I'll pause for a second and ask, wait for you guys to ask questions. Salam Anas, how are you? Yes, Pika. Those were different types of reactions. Abdul Rahim gave me a good equation. Pika, if you want to ask your question again. Right, easy, right? Okay. So if one says this equation is oxidation, the other one says combustion, they're both right, right? But that doesn't mean not all combustion reaction, or all combustion reactions will be oxidation reactions, obviously, because oxygen is always involved. But not all oxidation reactions could be combustion reactions. Carbon in air to make CO2, that's exactly what you do when you're barbecuing, right? Charcoal is, coal. So don't go there. Every time I say something obvious, my friend there snickers and makes me laugh as well. Okay. ठीक है. So yeah, coal, I'm sure you've seen it. You do produce. Acha, yeah, that's another thing. When you're burning coal, a lot of black smoke comes out, and carbon dioxide is not black. It's colorless, completely undetectable. It doesn't have a smell. So why is there so much black smoke coming out? Black smoke is essentially unburnt pieces of tiny little carbons coming out. And also included carbon monoxide, which is produced when there's not enough oxygen. So if you really, because a lot of oxygen doesn't reach the carbon when it's heating up in time, and that causes incomplete combustion. For example, air is only 20% oxygen, not all of it. Yeah. ठीक है. All right, does this make sense? Let me move on. The combination reaction we here, and we also highlighted a few other reactions, but we didn't go too far. So combination reaction is when two things when multiple things will react to form one thing. That's combination. And combustion is something reacting with oxygen to give off heat and light. And generally that's a good fuel source. So hydrogen reacting with, in our example over here, hydrogen reacting with oxygen is not just oxidation. You can also call it combustion, because hydrogen reacting with oxygen produces a lot of light and heat. So welders have a tank of hydrogen, and they weld it, because the heat is so strong, the welding torch gets so hot because of the hydrogen as a fuel, it can weld metals together. Hydrogen is also rocket fuel, liquid hydrogen. It's such a good fuel, they use it for rockets. Okay, so I know this is a combustion reaction because it's also used as a fuel. It gives off heat and light because of the welding example. Okay. Another example, a different kind of example for combustion. Okay. What's next? I'm welcoming questions if you have right now. Okay. Now someone talked about a displacement reaction. Let me talk about that. A displacement reaction. Displacement reaction is, I think we already did one particular example. No, not really. Okay. Yeah, aside from the neutralization. A displacement reaction is when one ion or one part of the molecule one part of the molecule is displaced to another molecule, right? And the good example we just had was highlighted by Saad was okay. This is an example of a displacement reaction, and specifically it's a double displacement reaction where it's not just the OH that's being, or like you can argue what's being displaced really, but not just the OH is being displaced, but from over here the chlorine is displaced. So there's a switcheroo going on. So the OH goes there, the chlorine goes here, and both of them just switch. So I like to see them as dancing partners, and they just switch their dancing partners. All right? Does this make sense? This is a displacement reaction. But the more technical of you will say, no, sir, this is a neutralization reaction. What are you talking about? Neutralization reaction. Yes, a neutralization reaction is when an acid reacts with a base or an alkali. Let's go with alkali. Acid reacts with an alkali to form salt and water. And that's specifically what a neutralization reaction is. Okay. And that's exactly what's going on over here. Hydrochloric acid is an acid and sodium hydroxide is a base. Now, if you don't know your acid and base theory, don't get intimidated and just just be aware, okay, we'll be doing this soon, probably by next week, right? We'll start this. But if you find this intimidating or you haven't ever studied acid and bases or acid and alkalis, it's completely fine, right? Just know there's something in chemistry that's called an acid and a alkali or a base. Okay. Does this make sense so far? So there are two names for this particular reaction. You can call it a double displacement, but more accurately, it's known as a neutralization reaction. Okay. So what have you written in the first product? NaCl and water over here. Is it not clear? I thought I was the one with the better handwriting. Okay, let me just check YouTube comments. I have a neutralization by definition, produces salt and water. Yeah, neutralization will produce salt and water. It's acid reacting with an alkali, produces a salt and water. Okay. Okay, let's move on. Okay. Why do I have combustion showing up? We did talk, I think combustion is straightforward. I don't want to. Salt plus H2O? Oh, this is salt, yes, sorry. Oh, this. I have the worst T's in the world. Okay. It's salt. Every time I write it, it looks like a saw. I've written saw. Take it. Okay. All right, here's one that confuses people because it's just a funky little word. Precipitation reaction. ठीक है, precipitation reaction. And it's when two aqueous compounds, when an aqueous compound reacts with another aqueous compound, it can form many things, right? Could be anything, but at least one of them needs to be a solid. ठीक है? And if that's the case, that particular reaction is called a precipitation reaction. ठीक है? Not only that, the solid part, what is produced, is known as a precipitate. Precipitate. ठीक है? Why can't I have the comments on top? Does this make sense? It's 5:40. Oh, I thought I was going fast. And it's darker now as well. The sun's setting. Natural lights today only. Okay, does this make sense? People aren't saying anything, so I'm just confused. So I think everyone understands this, so I'll just move on. But the important part is what this visually looks like. This is a very important type of reaction when it comes to labs, because what you have is solutions put together and you mix them together and they form a precipitate. Now how it forms, how a precipitate forms, is very cool to look at as well. I wish I had saved a picture of a precipitate. I can't right now, but like a precipitation reaction to show. But what it does is it's like this powdery substance shows up all over. The room is getting darker, yeah. So it looks very unique, and that's a good test for certain kinds of chemical reactions. If a precipitate is formed, it's then you can use that signal to because it's such a visual reaction. Like acid and base reactions aren't visual. You mix them together, and if they're dilute, they won't produce heat, but there will be no color change or anything, right? But if you mix, if you form a precipitate, a solid is formed in a clear liquid, that really makes it really obvious. So yeah, so lab mein you'll see a lot of precipitation reactions. It's just a fancy word for like a solid being formed. Yes, I should give an example of a precipitation reaction. Here's one. I should just write it here. It's 2AgNO3 reacting with, why is it hitting that? Magnesium chloride to form 2AgCl. 2AgCl and magnesium nitrate. NO3 twice. ठीक है. And right now you don't know if it's a precipitation or a reaction or not. You can't tell. But look over here. Aqueous, aqueous, solid, aqueous. ठीक है. The solid implies what? That it's a precipitate, right? It's just a solid. Just the word precipitate should be synonymous with the word solid, and you'll have an easier time. It's just a fancy way of saying solid. ठीक है. Let me see if I can get this question over here so you guys can try it. I hope I can. I hope it looks fine. I hope it looks fine. Now it's taking forever to copy. Okay, it won't. Now my iPad froze. Can I? Oh, this is showing? This shouldn't show. Oh, because it's sharing screen. O level. And this thing. All right. ठीक है. So that won't copy. There was a question I had saved. It won't copy. Fun times. ठीक है. Okay. All right. I think we're closing towards the end of the kind of reactions we have for just regular chemistry. I'm sorry. Stop with the likes hurt, man. Come on. The dislike hurts. Sorry, it wouldn't copy. I can't do anything. Okay. There's also another kind of reaction. Sorry, my apologies. I don't know what to do. Reversible reactions. Now, reversible reactions are not... A reversible reaction is a bit more complicated than just for a specific kind of reaction. It's more complicated, and we'll do it more in great detail in rates. But it's a really cool thing that's going on, and we'll do it there. But just know there's this thing called reversible reaction. ठीक है? All right? I can't, it'll take me at least 20 minutes just to start talking about it. ठीक है? Okay. Now I have a question right now. There are a lot of kinds of organic reactions. And they have their own specific names for it. Now, how many of you have done organic? Should I mention organic reactions, or is that okay? Or should we do this later, much later? I think it would just confuse people if we do organic reactions right now. Plus, we're almost, we're touching the time. Later? Okay, I think it might confuse people because But does this make sense? Right now, I want you guys to ask questions. Yeah, people haven't done it. I think this is around the time people start. Yeah, let's do it later. Okay, ठीक है, that's fine. ठीक है. अच्छा, let me tell you this. If there's a reaction called, why is my Mac clicking? If there's a reaction called hydrogenation, what do you think that means? What do you think that means, hydrogenation? And what if we don't ask questions because we don't? Addition of hydrogen? Yeah, when something gets hydrogen, right? Yes, you're absolutely right. And the example, I don't want to be guilty of introducing organic, but the best example is C2H4 reacting with hydrogen to form C2H6. It's just that. ठीक है. Is this a redox reaction? This is on the left is called ethene. First question is this a redox reaction? Or maybe, I think the easier question is ethene undergoing oxidation or reduction or neither? Is anything happening to ethene? What do you guys think? Reduction? Why do you say reduction, Saad? How do you know? In fact, nothing. Noman says it's nothing. I wouldn't disagree with him, but I wouldn't agree with him. I don't know, I'm joking. ठीक है. No, it's oxidation. Remember the definitions for oxidation and reduction we had? This is where, it's really difficult to figure out because you don't really see exchange of electrons going on. But remember our definitions for oxidation and reduction. One had hydrogen in it. Like, for example, gain of oxygen would automatically be oxidation. Yeah, you just have to remember it. It's not hard. You just have to remember those 3 lines, the definitions. And if you know one for oxidation, just remember one for oxidation. For reduction, it'll be the exact opposite. Let me bring that up. Where did I write it? Where did I write it? There we go. What is the gain of hydrogen? Because ethene is gaining hydrogen. Yes, it is. Gaining of hydrogen is reduction. So what's happening to ethene? Reduced. Ethene, good. Ethene is being reduced. But it's also hydrogenation because addition. So I could just say all of hydrogenation, any reaction that's hydrogenation of anything is also reduction of that thing. If anything is being hydrogenated, it's also being reduced. Does that make sense to people? My second part B of this question is this a redox reaction? Is this a redox reaction? Why do you say that, Mariam? Why is this a redox reaction? Why? Yes, Abdul Rahim online is saying, my first dislike, I think, or YouTube, I'm heartbroken. All right. My first dislike on YouTube. Take it. Can someone explain why this is a redox reaction? Wherever? Yeah. Yeah, because wherever reduction is taking place, oxidation is too. If someone's getting richer in the world, someone else is getting poorer. The easiest way to look at that is if you go to a store and buy some chips. You get poorer when you give in money, but the cashier gets richer because he takes money, or the store gets richer because they take money. Okay. So if someone is losing their electrons, the other one has to gain electrons. If you see reduction happening place at one point, whatever's next to it is also being oxidized. Oh my God, now I'm being spammed by dislikes. Okay, 2 dislikes. Why the dislikes? Can I get a reason? Okay, never mind. I'll get more if I keep talking about it. Oxidation states are changing. Iman online says oxidation states are changing. Yes. But the more quicker Iman answer I was looking for was that if something is being reduced, the other thing is being oxidized. ठीक है. ठीक है. Why do I get likes at the end? All right. Any questions? Can I end it here? Is that okay? Oh, 7 likes. Nice. Nice. Thank you for your likes, guys. Thank you. Thank you. Ooh, wow. Okay. Can someone tell me on YouTube how many people are watching? Because normally I see 4 people, but they're like 16 likes. So I don't get that. So do you want 10 or maybe 12? Likes? No, I don't want to be greedy. I think don't go to that thing and start liking it from your different accounts. Don't do that. That's just... Oh, it's never accurate with the likes and viewers? I did not know that. I know... Oh, acha, I know what you mean. Okay. So yeah. Okay. Okay. All right, I'll end it here. Any question from YouTube? I'll just pause for a minute because there's a delay. But consider this class done unless we get a very... Yes, Pika, you're saying something? Is Pika from Pikachu? Is that inspired from Pikachu? I think there's a Pikachu. Oh, yeah, okay. 12 pp? The 12 people? Okay, that's great. That's great. I hope you guys understood something. I wanted to have a more, like a 20-minute class, but it turned longer. But it's good. I think everyone followed, everyone understood. So don't get confused when someone says oxidation versus combustion. You know, like, yeah. Chalo guys, take care. I'll see you when? I'll see you. I think it's Saturday, right? I keep forgetting. No, it's Friday. Khuda Hafiz, guys. Khuda Hafiz. It's Saturday with me? Okay. I'll check my timetable before anyone else is confused. Let me check my timetable. There we go. It says Friday. Where Friday? Team Friday, man. Team Friday. Woo! You play Osu? Okay. Bye-bye, guys. Take care. 5 to 6. Wednesday and Friday. Thank you, Sad. Bye-bye, guys. Take care. I think we'll do new topic. Something new. ठीक है? On Friday, yeah. I'll let you guys know on Friday, right? ठीक है? Bye-bye, guys. Take care. Thanks for coming. All right. Just ending. Whoop.